Hello, dear viewers. I'm Dr. Shikha. I'm working as assistant professor at ABES Engineering College, Ghaziabad in the Department of Applied Science and Humanity. So today I'm going to deliver a lecture on fibers. Fibers are basically thin, long, and thread-like material which have high tensile strength. And the strength of a polymer basically depend upon the chemical bond which is present in the polymer chain. If we discuss about their shape, the shape is basically linear, and the linear shape allow the polymer to be side by side alignment. This alignment is due to the intermolecular force which inhibit one molecule from slipping over the other. The intermolecular force might be van der Waals force, which retain the stereoregular chain of the isotactic PP polypropylene in the aligned way, or it might be dipole-dipole attraction, which maintain the chain of the polyester in the aligned way, such as decaron or terylene, or it might have the hydrogen bonding, which remain the chain of the polyamide in the aligned way. Example is nylon. If we discuss about the use of the fibers, they are used in the clothing application. For a polymer to be used for the clothing application, its melting point should be greater than 200 degrees C and lower than 300 degrees C, so that ironing can be done without the damage of the material. Also, they should have TG that not be so high that iron is ineffective. Example of the fibers are nylon 66 and PET. PET is basically polyethylene terephthalate. Now we will discuss nylon 6. So the nylon 6 can be synthesized by the self-condensation of of aminocaproic acid, or it might be synthesized by the ring opening polymerization of caprolactam. The self-condensation of aminocaproic acid can be done because it have two types of functional group on the both side of the chain. One side it have acid group and the other side it have amino group. So self-condensation reaction can take place and the nylon 6 can be synthesized just by the self-polymerization. Why we are saying 6? Because it contains 6 carbon in the chain, and it can be prepared by the ring opening polymerization of the caprolactam. So how this is synthesized? It is basically the stepwise synthesis. First, we will start from the cyclohexane, which is a 6-membered cyclic ring, which on the oxidation form cyclohexanone, and in the next step this cyclohexanone is converted into cyclohexanone oxime by the reaction of hydroxylamine. So here elimination of the water molecule take place and the cyclohexanone oxime synthesis take place. Then this cyclohexanone oxime on next step is converted into the caprolactam by the, it is basically the carbon to nitrogen rearrangement that is known as Bachmann rearrangement, and here expansion of the ring take place. So as we can see, it was a 6-membered ring. So after the rearrangement, it is converted into the 7-membered ring, and here amide bond form. So it is basically 7-membered ring, which is known as caprolactam. So this caprolactam, after the ring opening polymerization, form nylon 6. Now we will discuss about nylon 66. So nylon 66, first we will discuss what the 66 represent. First 6 represent the number of the carbon in the diamine chain, and the second 6 represent the number of the carbon in the adipic group. So nylon 6 basically prepared from hexaethylene diamine and adipic acid. It is also example of condensation reaction. Here also the removal of the water take place and amide bond form. So the property of the nylon, it is basically linear in the structure and have side by side alignment. Furthermore, it have hydrogen bonding which maintain the molecular chain together. Also, due to the hydrogen bonding, it have high crystallinity, it have high strength, high melting point, toughness, abrasion resistance, and good mechanical characteristic up to 125 degrees C. They are also subtilizable, both nylon 66. Also, due to its polar polymer, nylon 66 is basically a polar polymer, as we can see from the structure also. So they have resistance to hydrocarbons. Also, as we know, larger the number of the carbon atom, it is basically simple to process and it improves the resistance of the moisture as the number of the carbon atom increase in any polymer. So now we will discuss about its application. It is basically used as fiber and used in making socks, undergarments and carpet. It is also used in mechanical engineering for the well-known applications such as gears, braking, buses, and camps. Apart from these property, nylon are frequently operate without the lubrication. The moving part of the nylons do not need any lubrication. Molding having application in medicine and pharmacy. Also, these are used in hair combs. Nylon 6 also used in jacket electrical equipment. It is also used in tire coats. Now we will discuss another fiber, that is PAT, polyethylene terephthalate. PAT can also be prepared by two way, either the direct reaction of terephthalic acid with ethylene glycol, or terephthalic acid is first converted into dimethyl terephthalate and then the reaction with ethylene glycol. So we will discuss step by step. First, in the step first, terephthalic acid is reacted with the methanol. Here also the elimination of the water molecule take place. And diethyl terephthalate form. Then this dimethyl terephthalate is further reacted with N molecule of ethylene glycol and form PET, polyethylene terephthalate. It can also be prepared, as I had discussed earlier, direct reaction of terephthalic acid with ethylene glycol. It also gives PET and the removal of the water. So what is the reason to first to convert into dimethyl terephthalate? Just to make the reaction easy, because the ester exchange is the fast reaction comparison to terephthalic acid. Acid reaction with, here what we can say, acid is going to react with OH, and in the last step ester was going to react with OH. So ester reaction with OH is most of the cases are faster reaction than comparison to the acid. And now we will discuss the property of the terephthalate PAT. It is rightly crystallized because of the symmetrical structure, and it have contained various polar groups. It have good resistance to hydrocarbon solvents as well as moisture. Also, it have mechanical properties, very good mechanical properties such as tensile strength, tear strength, impact strength, and it retain up to 120 to 175 degrees C. It is good fiber forming material, outstanding craze resistant, low moisture absorption. They have more durable. And basically oriented films and bottles of the PET are transparent. They have excellent strength and barrier property. Glass filled PET molding have superior mechanical property and high temperature resistance. Also, PET can be blended with the wool fiber, which improve crease and wrinkle resistance, and more resistance, do not shrink, and are not moth attack. The blends have superior finish as well. If we discuss about its application, PAT is basically used in magnetic recording tapes. Films, as we have discussed earlier, also these are basically transparent and have good barrier properties. So they are used in scholar drink, fruit juice, etc. Wide neck jar of the copy also prepared by the PAT. Glass filled PET moldings are used for housing such as coffee machine, car heater, and water meter. Terethylene fiber, as we have discussed here, also can be blended with wool, and they have the superior finishing. Now, these are the references. Thank you. That's all from my side.